Hello, my name is Ayush Shakla and my roll number is IC2K1703. This video is my college assignment. We use computers freely, but most of us never bother to know what's inside the box. Why should we? After all, we need our computers only when playing games
Oh shit, here we go again.
or browsing the web. We never care to find out how this keyed box manages to convert and fetch binary data from the internet into pictorial representations. Yeah, I do mean memes. You can certainly use computers without knowing what it's made of. You can even use the internet to copy most of your homework from Google and use different word processors or spreadsheets. As long as you continue to get all those reports and chats and are able to watch your movies, you don't really need to know anything else. But sometimes the inevitable happens. The great crash occurs. And your files or work gets corrupted, or even worse, your machine refuses to boot and you get introduced to the term an operating system. You have heard the name, but you don't get what this magical software does. Now this special piece of software is what differentiates your system from a brick and gives it life. Every computer needs some basic intelligence to start with, and unlike us mortals, a computer is not born with any. This intelligence is required for providing services for the programs and give it some environment to run. The operating system also provides the user with resource management services that can further ensure a smooth operating of the system by allowing the users to use file management system and even managing the running programs, also known as processes. Spoiler alert. Now, without an operating system, even the most powerful computer in the world would be a useless monster.
It's useless, 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 useless!
There have been many operating systems in the past, namely DOS and Windows, but
No, there is another.
Unix arrived earlier than the other two and was way ahead of them in terms of sheer power. It has practically everything an operating system should have, and several features which other operating systems never had. Its richness and elegance go beyond the commands and tools that constitute it, while simplicity permeates the entire system. It runs on practically every hardware and provided them inspiration to the open source movement. However, Unix also makes many demands of the user. It requires a different type of commitment to understand the subject, even when the user is an experienced computer professional. It also introduces certain concepts not known to the computing community before and uses numbers of symbols whose meanings are anything but obvious. It achieves unusual tasks with a few keystrokes, but it takes time to devise a sequence of them for a specific task. Often, it doesn't tell you whether you are right or wrong. It doesn't warn you of the consequences of your actions.
Oh, okay.
You interact with the Unix system through a command interpreter called the shell, key in a word, and the shell interprets it as a command to be executed, which makes the operation look like this and not like this. A command may already exist on a system as one of several hundred named to it could be one written by you. However, the power of Unix lies in combining these commands the same way the English language lets you combine words to generate a meaningful idea. Unix works on two imperative units, known as the shell and the kernel. Both the shell and the kernel are parts of this operating system. These both parts are required for performing any operation on the system. And when a user gives this command for performing any operation, then the request will go to the shell parts. The shell parts is also called as interpreter, which translates the human program into machine level language, and then the request is transferred to the kernel. So that the shell is also called as an interpreter of the commands, and it converts the user request into a machine level language. Now the kernel is also known as the heart of the operating system, and every operation is performed by using the kernel. When the kernel receives a request from the shell, it will process the request and display the results on the screen, or even provide the output to the shell to display it. Now for the second part of the video, we will discuss some of the questions that are given in the UNIX book by Sumita Badass. Coming over to a few questions that were given in the book. The first question is, enter this command sequence ls pipe symbol wc-l. What do you think the output represents? On writing down the command ls pipe symbol with wc and the option -l, the output is like 12, and it happens because of the fact that ls lists out all the files, and the pipe symbol redirects the output of ls into the wc command, and the wc along with the option of -l gives us the number of lines, which eventually gives us the number of files that are in the directory. For example, let's check out ls. Now I have around 12. I'll just count it for you. Few files. I have 12 different directories or files, and the word count just gives me that. To understand this command in a brief manner, we will check the functioning of each of the commands. ls, for example, is a command line utility for listing the contents of a directory or directories given to it via standard input. When we won't pass anything to it, it will just list out all the files of the current directory, and it did that. Now the pipe symbol redirected the standard output coming from ls into the wc command. wc command means word count, and word count alongside the option -l gives out the number of lines. Now the number of lines in the given by the ls command were like 12, and that's why we got the output. Question 2. Enter the two commands echo star and ls. What do you think echo did? Now for question 2, we'll write in echo alongside star, and we can see the output is not similar. It's like, okay, the output is same as ls, but it's a bit different because we don't know which of these are directories, as the directories were blue in color when we used ls. Now there's a huge difference between both echo and ls. The output of echo was cluttered, and it was due to the fact that echo prints out everything that is passed to it, be it a string or a variable, and echo star just echoes the name of the files and directories in the current directory. And similar to that, ls lists out the names of the files and directories, but it also lists out the content of the directories instead of just giving their names. Question 3. Enter these commands echo $shell in double quotes and echo $shell in single quotes. What difference do you notice? For the output of question 3, I'll execute the commands. First, I'll write echo alongside $shell in single quotes, and as you can see, $shell is printed as it is. There's no change, there's no difference between what was there in single quotes and what's printed. Now I'll run echo alongside $shell double quote. And it's hidden because I don't know why it's hidden, but the difference is that $shell was actually going to display the shell that I was going to, or that shell that I'm using, and here my shell is bash. I don't know why it's not displayed, but it was supposed to display that. To describe it in a briefer manner, single quotes won't interpolate anything, but double quotes will. For example, the enclosing characters in single quotes preserve the literal value of each character within the quotes, There are no exceptions. However, a single quote may not occur between single quotes, even when preceded by a backslash. Whereas, coming about to double quotes, the enclosing characters in double quotes preserve the literal value of all characters within the quote, with the exception of a few special characters. And when history expansion is enabled, these characters retain their special meaning within the double quotes. Therefore, $shell variable was echoed out when we use double quotes, whereas it was printed as it's supposed to be when using single quotes. Question 4. A program is synonymous with a process. True or false? A program is considered to be a executable file which contains a set of instructions written to complete the specific job on your computer. For example, Google Browser Chrome.exe is an executable file which stores a set of instructions written in it which allows you to view web pages. Programs are never stored on the primary memory in your computer. Instead, they are stored on a disk or secondary memory on your PC or laptop. Even in UNIX, the programs are written and stored somewhere else. They are read from the primary memory and executed by the kernel. Whereas a process is an execution of any specific program. It is considered as an active entity that actions the purpose of the application. Multiple processes may be related to the same program. For example, if we run another shell via the first shell, it will be considered as a running program or a process. The features of program are that a program is a passive entity. It stores a group of instructions to be executed. Various processes may be related to the same program. A user can run multiple programs where the operating system simplifies its internal programmed activities like memory management. The program can't perform any action without a run. It needs to be executed to realize the steps mentioned in it. The operating system allocates memory to store programs and instructions. Now coming over to the features of a process has a very limited lifespan. They also generate one or more child processes and they die like human beings. Like humans, even process has information like who is a parent when it is created, the address space of allocated memory, security properties, which includes the ownership credentials and privileges. Processes are allocated system resources like file descriptors and network ports. Question 5. Who are the principal architect of the Unix operating system? Unix was created by Ken Thompson, Dennis Ritchie, Brian Kernighan, Douglas McLeroy, Joe Osana at Bell Labs